Here we go. Okay, ready, ladies and gentlemen. So let's go over here and let's go to state chart, and we're going to put in a final state. Okay, and this state will be called death. Okay. Now, a final state is a little bit different than others in the sense that it's something which many state charts can be connected to, not just one. But we're going to add in mortality transitions with appropriate hazard rates here from susceptible, infected, and from recovered. Okay? We okay with that? Okay. Ladies and gentlemen, let's make each of these transitions a rate transition. Okay, now, I would like you to note, as an opportunity for learning, that there's a problem with this current diagram. And it's a problem that's been latent. It wouldn't be revealed for a bit, but it could be a real issue if I don't correct it. Does anyone see something wrong with this picture? There's a major, well, a significant issue that would adversely affect functioning.
How would you observe the effect of this problem?
You would observe it visually by noticing something's not right. I noted yesterday that the color green is an important one for transitions being added. Green is for good. Green is the color that you want.
There's another hint, though, that there's a problem, right?
Yes, there is.
One error.
There is a problem, as indicated by this hanging transition. But what's wrong visually here?
Red.
Yes, and this is disconnected. This is not green there. See that? So it's a close call. You might think it's connected visually, but it's not. In order to connect it, it needs to turn green. Boom. And then, as Sean noted, it will turn from red to black. Moreover, as Kurt noted, the error disappears. Okay? So just watch out for the end of transitions there. This is not a game of horseshoes. And you need it to actually connect. Are we okay with that? Okay, ladies and gentlemen, let's associate this with a higher hazard rate. Let's have the this transition. I'm going to show names. This will be dying susceptible. This transition. Often we name transitions with action verbs to indicate that it's kind of something happening. With infective transition, this is dying infective, and we should show the name. And then with this final transition, this is dying recovered, and we should show the name here. Okay, now, suppose we wanted a hazard rate that's different. The hazard rate, perhaps, for dying susceptible is just 1 divided by 1,000. Please make it 1,000.0. 1 divided by 1,000 would evaluate to what? Does anyone remember from my description from yesterday? This turns into what? 0. It says how many times does 1,000 go into 1 as an integer? 0 times. This will give you the correct number, or if you want to be sort of even more specific, that you could say. But as long as one of them is a floating point number, it'll perform floating point division. If neither is a floating point number, it'll perform integer division. That's the tyranny of Java. Okay? Okay, and same thing with this one here, 1/1,000.0. Okay, for dying infective, let's make this a higher hazard rate of 0.01, or 1 divided by 100, 10 times higher hazard rate. Now, sometimes we have hazard rate ratios that we know empirically, and we can encode them with an appropriate beta. We might even for some boot camps, I'll even tie this in with biostatistics. I do quite a bit of survival analysis, competing risks analysis, and recurrent event analysis, where you'll have often formulations, which would be of the form, the hazard rate would be of the form, exponent some beta 0 plus beta 1 times some covariate 1, some risk factor plus beta 2 times some covariate 2, and moreover, it might be time variant. So you have it times some baseline hazard rate that's based on how long someone spent in the state. Those things are all you can readily insert those if you wish to do so, and you will find example models. In fact, some of those I've given to you, I think, may use those formulations. Okay, those formulations, traditional and biostatistics, dynamic analyses, such as with competing risks and survival analysis. So we can readily put those in. I'm not doing that right now, although I'll be glad to do so in another example if there was interest. Okay, so right now we put in different hazard rates to death, and now we have the death state, and this is where the action's at. So this is where we need to remove the person, okay? Now, there's several ways that we can remove this person. And I have my preferred way, but there is a way called delete self that's very simple, okay? And if you have, there are some shortcomings of this. If you have a model which includes hybrid discrete event components, this can cause issues. You notice throws error, each belongs to a flowchart block if it's in a discrete event model. But as a general rule, this is the simplest way, delete self, okay? You can also alternatively say main dot remove underbar population, remove myself. This is another way to do it. I think the simplest is to probably do this for now. Remove self, okay? So now people die whilst infected. They die with a 10 times higher chance, a chance of 1 out of 100 per day. They only have 1 out of 1,000 per day chance of dying in the susceptible and the recovered state. Okay, can we run this? So, does anyone need me to show this longer? Delete self. Notice it's up on the board. It's up on the big screen there. Delete self. Are we okay? Do you want to run it? And what shall we see? What do you think we'll see?
People leaving the network.
Yeah, people leaving the network, people coming into the network. There's mortality, and there's spread. Now, let's add a bit of texture to this model. This model's, I just closed my logic. Okay, I'll challenge you. I'd like you to add a waning of immunity transition, which goes back to susceptible, following a delay of a certain number of time units. So a certain duration of immunity, which will be specified as a parameter in main. It will need to be specified by experiments. So how do we do that? Can anyone tell me? Start with. We want to have a waning of immunity transition. It's going to be a timeout with a, well, let's make it a rate transition. With a mean time that's going to be specified of a certain number of days. How would I do that in this model? How would I have waning immunity? What would I do? I'm trying to make sure you're feeling some comfortable with basics. What would I do?
So go to the state chart tool.
Good.
Create another state waning immunity.
Well, we're going to assume that recovered reflects immunity.
That's right. So just go straight with a connection.
Okay. To where?
From recovered
Yeah.
to susceptible again.
Good. And how do we make this transition go around this obstacle? We can drag a handle on it. Okay. Here we go. Now this is showing the non-planar character of this graph is showing awkwardly. You have these two crossing transitions, but I think it's an irreducible non-planarity. So I don't think there's much we can do about it. In other words, we can't rearrange things because we've got these death transitions. No, actually we could. Okay, there is a clever way we could do it. Yes, we could do it. Yes, we can do it. Do people want me to change this into one where it doesn't cross? Probably you don't care. But Kurt, you could move this over there, move these ones over here, and actually we would do it. Okay, so yeah. So we were going to have this represent waning immunity. There's no problem with crossing transitions, except visually it looks a bit jarring often. Waning immunity is going to be the transition name. Let's show the name, waning immunity, and let's make it a rate, and its rate is going to be 1 over some parameter value. The parameter value will be specified in main, and this parameter value will be in main, and it's called duration of waning immunity. Okay, duration of waning immunity, and it will be what sort of type? Can anyone say? What sort of type will this be? It'll be yeah, it's a good question. We're going to actually write explicitly 1 over this. So we could either specify it as a waning immunity hazard rate, in which case it would be a rate, or we could specify as the actual rate is 1 over this time, in which case we'll specify this as a time. Okay? So we'll specify as a time, and its units will be in years, and its default value will be 1 year. Waning immunity of 1 year. You have 1 year of waning immunity on average. Perhaps it's like flu. Okay? Duration of waning immunity. Okay? And now for the person, we're going to have a rate of 1 point, well, yeah, we could do it to be safe to show this general principle. 1 over duration of waning immunity. And this is going to be, well, it's going to be 1 over per year rate. Per year rate. Okay. When someone's waning immunity occurs, they'll go back to a susceptible state. Okay? Okay. What did we just do? We added a transition into susceptible. The person will follow that transition according to a rate. We set the rate to be 1 over this parameter value, which lives in main. Hence we have to say main's parameter. This dot means sort of the duration of waning immunity in main. Main's duration of waning immunity. And this is a per year rate, and I went over to main and I set a duration of waning immunity defined in years with the default value of 1. Are we okay with that? Ladies and gentlemen? Okay. So that was just a reminder. And I'm sorely tempted to fix this up. So pardon me Oh, man.
Resist.
Okay, there we go. Hey, there we go. Okay, boom. And then this thing can come over here and this thing can be connected on this side if susceptible, and this thing up on this side, and this one down like this. Okay, and then this could be brought in like that, and this guy could be brought like that. Okay, that's a little bit better. It's not quite as bad. Okay, dying infective. This guy needs to be like that, and this guy needs to be repositioned. Okay, that still ain't pretty, but I think it's maybe a little bit better than before. Okay, dying infective, dying susceptible. Okay, apologies for the aesthetic affront. Okay, this could be prettified. Okay, like that. Okay, great. Okay, so ladies and gentlemen, this needs to be routed around in this one over here. Okay, there. That's not abysmal. Okay, great. So we can run this now, and we will run this, and what we should see now is coming in, but people should be losing immunity as well. So there's continuing sporadic outbreaks. People become susceptible again over time. Their immunity wanes, and then what's happening with these little outbreaks? What's happening? Can anyone say? What's going on here with these little outbreaks? Well, part of it is immigrants are bringing in a rather high fraction of they have a rather high prevalence, so they're bringing in, and it sort of disturbs these local networks of susceptibles that form after a while. Okay, so bit of a glimpse there of waning immunity. Maybe what I'll do, just because we're on the cusp of lunch, right, so I could add births. Okay, let's add in a birth transition. Ladies and gentlemen, let's add a new state chart into person. Okay, so let me just save this. So I added mortality. Okay.